we started the recording. So yeah, as I was saying last week, we did a couple questions. We took a look at actually answering. Well, let me share the screen just to recap. So that's you, right? So we did the question on gas as an algorithm essentially, and we also took a look at, of course, not just the gas question, but we took a look at the shelf question. The gas one was, of course, to determine the amount you would pay for gas to reach to cover a specific distance. And of course, the next one was given a shelf of a particular depth, right? How many 1 square foot panel boards would you need to build that shelf, right? If that shelf always has 3 shelves in the middle and 2, of course, a top and a bottom shelf, and shelves on the side, right? Side panels on the side. We also took a look at doing the triangle question, of course, with taking a look at the logic behind identifying, well, how can we know if 3 values would form a triangle. We wrote some code in class last week as well, in no particular order. Okay, so this was the code for, I believe, the triangles. It utilized the if statement in C, and we took a look at expressing the logic to make sure, to ensure that the if statement could determine whether or not some values entered would form a triangle. We took a look also, I think, because it was our first week, just some basic output. This was our Hello World program, pretty much the first program that anybody tends to write. Okay, so we took a look. We know that we had to use the printf statement to be able to output some value to the screen, and we took a look at essentially programming structure. We know that we have to include stdio.h and stdlib.h libraries. We have how to comment, how to write comments, and we identify that comments allow us to really and truly leave notes for ourselves or other programmers who might have to interact with this program in the future. We have, the output statement, as I identified before, return statement. That's not for us to use now, of course, but later on we will all learn how to use functions and the purpose of return statements. And then we moved on to, or then we did this program here. And remember what program 2 does off the top of my head. Okay. So, and again, it just simply allowed us to utilize input. So we saw that we use the scanf function. Okay, I'll highlight the line to accept a variable. Okay, and we had the %d being a placeholder for an integer. So if it is that we are telling the computer to expect an integer, we have to say %a as as an argument of this that we pass into the scanf function. Okay, and what this will do is that this will take whatever integer value the user has written into the program, and it's going to store it into the the %a, right, or the and sign a. We had a second number, and we did an operation adding the first and the second number, and then we printed out the sum of the 2 numbers. Okay. And the last thing that we did was that we took a look at basic loops, right? Really and truly, we took a basic look at loops. So, and this is where we want to continue from today. We want to be able to, write a program and explore the different types of loops. We spoke about the different types of loops in a previous a class where we utilize where we utilized the pseudocode to do it, and we identified bounded and unbounded iteration. But we really only took bounded iteration as an example last week. So hopefully we could get some unbounded iteration examples in this week, right? We want to mix loops with if statements and see how we can get different values and patterns to print out. Maybe we could have loops within loops as well. And let's see how, when we combine certain things, how things work. So everybody's fine with this. Everybody is up to speed on where we're at in terms of our recap. Any questions? Yes. Or anybody have anything that they feel like I should have addressed up to this point that I did not address?
Well, so for me, I still had to watch the past 2 weeks videos.
Okay, so you still catching up a bit in terms of knowing generally what's going on.
Yes, but I'll be listening and paying attention.
Okay, well that's good. I'm glad you're here because you could catch what we're talking about here, and then watching the previous videos will put things into perspective for you. And then what will happen is, when you watch them and then you think about this video, and then even if you watch over this video or parts of this video, you might just be like, that's exactly what he was talking about. And now in context, it's going to make absolute sense. Okay, so you're doing well. You're in a good place. You're taking the right approach. All right. So we're going to talk about loops, and I think a good place to start might be to just take a look at the 3 different types of loops that we looked at in pseudocode algorithms, which is the for loop, the while loop, and the do while loop. We're going to look at them in C. Okay, we're going to take a look at them in C, and then we will. There is another decision logic structure that I'd like to talk to you all about at some point. Maybe I won't get it in this week, but chances are by next week. It's the switch case structure. Okay, but that one is not as popular. Those are more used for like specific scenarios. So I'll talk about that decision logic structure. You could get along without it, but I don't want to move forward without mentioning it, or at least I don't want to end these classes without mentioning it. So if it is I don't mention it today, we can mention it next week. Is that fine?
Yes, sir.
All right. Thank you, that one person who responded, Johnny. All right. So we're going to move forward. I'm just going to switch my context. And as I always recommend that, you guys have your compiler open and ready to type once it's available to you right now. You could follow along, but it's always easier to type along because it's like you're doing the practice, right? But what I would say is, kind of watch and follow what I'm doing, and then try and write it up. I know that might be hard in terms of time, but kind of understand. Only write when you understand. If you don't fully understand, then it's better to probably just straight up pay attention and then practice it later when the video gets posted. But if it is that you're understanding as we go along, then yeah, go ahead. By all means, write it, get the practice in while it's being explained or revealed to you. Okay. All right. So we straight up into the compiler today. Right? We straight up into the compiler today. Let me share my screen. Screen. I want that single screen yet again. So, right, and it's all because I'm way too lazy to just take my laptop back to the room with the second screen. Right, but I mean, one screen, two screens, it'll work. We'll get stuff working. Okay, so I want to specifically do an example with for loop, while loop, and the do while loop in C today. Okay, and they're just basic examples. They're not like anything in specific to the like a problem. They're just to see how it works and to see the logic behind it. All right, so let's type up our include stdio.h, include stdlib.h, int mean return 0. All right, so this is not my folder that I was using. Supplementary classes. Right, C_files. Okay, so this first one, we're going to start with the for loop because we kind of took a look at it last week. So we have the for underscore loop.c, and we want to just simply, okay, this is an example program that will show us how to use the for loop. This program should take in a start value, a stop value, and a stop value from the user and print all numbers between these two values. There's one more thing I wanted to do with this. So we have a program, we have the start value being entered, we have the stop value being entered. We want to get all numbers in between the start and stop value. Okay? The program, let's add a little level of difficulty. The program will always move from the lower number entered to the higher number entered. So we could write a program and we could say, hey, as a program, let's simply, as a program, let's simply what you call this thing? Let's go from the smaller number to the higher number by letting them enter the smaller number first and entering the higher number first. And that'll be cool. That'll be cool. Except, it's we write in a program. A program should be smart. If we know that the rule is that okay, it'll always ascend, then it shouldn't matter if they enter the smaller number first or the larger number first. My program should find out which one is the smaller number and find out which one is the larger number and move from the smaller to the larger. So we're going to do something. I'm going to write the program at first, assuming that the smaller number will always be entered first. And we'll see the output. And then we will tinker with the program and add a little sense to the program, a little logic to the program that will make the program always find the smaller of the two and carry it from the smaller to the larger number. Okay? So we could start off with this. Anybody do understand what I'm saying? So everybody's fine, right? Good. I'm sorry, let's enter. Separated by E. comma. So we asked the user for two numbers separated by a comma. So we should have two numbers. What are we going to call this number? Right? These numbers, we could call them anything. We could call them, right? They have to be integers. And we can say N1 and N2. So we have N1 and N2. So let's take in N1 and N2. We have scanf. If it is two numbers separated by a comma, we go %D, comma, %D. Because this is what I'm asking for, right? Not just numbers, but integers. Right, two integers separated by a comma, %D, %D. So my computer knows that I'm asking for two integers. I want to save them where? I want to save them in N1, and I want to save the next one in N2. How am I going to know which one is larger? At this point, I am assuming that the larger value is going to be held in the second number, and the smaller value is going to be held in the first number. After my scanf, I need a get char because C just funny like that. Okay, we're not hating. So I could just put store the numbers. And then what do I want to do? I want to print out all numbers between these two numbers. Okay? And I want them inclusive, which means that I would like the two numbers that were involved to be included. Okay? So how do I do that? What type of loop should we use? Well, we know we have to use a for loop. Why are we using a for loop? Let me ask a question to somebody. Why are we using a for loop? Let's see my list of people. Jada, why is a for loop probably better to use in this scenario?
Because you're given a starting value and an ending value.
Correct. So Jada is correct. We have a defined start and a defined stop value. So we know, however, that for a for loop, we need to have a counter. So we can have I as a counter. And we can say for I, which is my counter variable, starts at N1, semicolon. So that's one statement there. In this counting, I will start at N1. What will I stop at? I will stop at N2. So I will continue to loop. I is less than or equal to N2. I will continue to loop for all values of I as long as that value of I is less than N2 or it's equal to N2. That's what the second statement is saying here. So I will continue to loop until I is bigger than N2, at which point it will stop looping. And then how do I move I from N1 to N2? I have my increment statement. My increment statement is I++, which is shorthand for I++ is shorthand for I is equal to I plus 1. That's just how it is. And we'll take a look at some other shorthands in a bit. Okay? So we have these values here, and then we'll say for every value of I, right? So for every value that I is, we want to print it out. So just simply printf %D, the number, put a space so that they're not jammed up together, and we're printing out the value that is stored inside of the variable I. So if it is I compile this, I have no errors. If I run this, I get my window saying enter two values, two integers separated by a comma. Okay, Porter, could you give me two values? make the first value smaller.
3 and 8.
And 8. Okay? Would you say that we've satisfied the criteria of what we're looking at so far, while making the assumption that the smaller value is first?
Yes, sir.
All right, good. So we have two integers separated by a comma, 3 and 8, and then our program tells us that yes, for every value 3 to 8 inclusive, we've printed it out. Now let's test this. Breaking the assumption now. If we use the same values that Porter gave us, 8 and 3, we get nothing. Why do we get nothing? Because what would have happened here, and allow me to pull up my marker, is that if I entered 8 here and 3 here, I'm saying for I is equal to 8, I is less than or equal to 3. But what did we establish here? We established that this second part says that only while this condition is true and I is less than or equal to 3. But if I starts off at 8, then what happens? And then you tell me go until 3. I can't even go in the first time because I'm not meeting the criteria that I set to stop, even on that first iteration. You all follow me?
Yes, sir.
Right. So that's why nothing prints out at all. Okay? So we have to put some logic here before the for loop now that will allow for this entire that would allow for this to make sense when I put in a value of when I put in a value that is larger first. What can I use to know whether to swap the values or not to swap the values? Let me ask a question to Anaya. Anaya.
You can probably use a if statement.
Right. So you want to talk me through? We say an if statement. So you're correct thus far. If what? If what, then what?
If N1 is greater than... I'm not sure how to sing it.
Okay, if N1 is greater than what?
N2.
Right. So if N1 is greater than N2, we want to switch the values inside of N1 and N2. Okay, and let's take a look at performing a switch. So to switch two variable values, if I have N1 here, and I'm going with the values that we had initially, 8, and N2 here, and I had the value of 3 inside of here, what would I need to be able to swap these two values? I need to have some kind of temporary variable that I could put the value of one of these into. 8. Then I could take this value, right? So this is the first thing. The second thing was to take this value and copy it into N1, and then take the value outside of temp, and then, so this is the third one, copy this into here. So now we have that N2 being the bigger value. Okay? So this is just simply the first thing that we did was that we said temp was equal to N1. Then the second thing that we did, we said N1 is equal to N2. And the last thing that we did was that we said N2 is equal to temp. Follow me? Yeah? So we're going to try
Yes,
it. We're going to put
sir.
it inside here and see it work. So what did we do? We said that temp is equal to N1, right? So we say here, if the larger value was entered first, then we'll swap the values. And swapping involves putting the value of N1 into temp, putting the value of N2 into N1. So N1 is equal to N2. And the next thing that we did was that we take N2 and put the value from temp there. So with this being done, we can now test. Okay, I didn't declare the variable temp, so I have to declare temp as an integer to hold an integer value. So with this being done, let's go back. And we can now go 8, 3, and it will print from 3 to 8. Disregarding whether the larger value was entered first or, right, so let's enter a large value like 6,753 and a small value, 47. Okay, so we have 47 going right up to 6,000 something. Okay, so we started at 47 and we printed right up to 6,000 something. Everybody's fine with this?
Evening, sir.
Hi. So, yeah. Any questions thus far? Yes, no?
No, sir.
Evening, sir. Sorry for coming late. What I miss?
We actually, who am I speaking to here? First of all.
Josiah.
Oh, yes. Yeah. We simply decided we recap last class and we just running through a simple program utilizing a for loop because we're taking a look at looping today.
Okay.
Okay. Right. So we have the for loop, and this is the code for the for loop. And all we wanted was for two numbers to be entered, and you move from the lower number to the higher number. And now we're about to go to the while loop. And we'll also have an example of the do while loop. Okay? So we're moving on to the while loop. Save, and we'll go right. So we're going to take a look at the while.c. Okay? And again, laziness will reign. Oh, sorry. Let me open back my I'll get to the address now. Right? I was hoping laziness could reign, but I had to type it over instead of having to go hunt for where I store those. It's in a folder called supplementary classes, but I can't even remember where I have that folder located. So, I have to go through the indignity of typing over these statements. What a horror. 0 and 0. All right. So we have stdio, stdlib, right? We set up. So what do we want to do with this while? Let's say, and remember, this is just to show the behavior of the while. We're taking a look at the straight while loop, and we identify that the while loop executes instructions 0 or more times. Okay, so it executes instructions 0 or more times. So what do we want to do with this? We want to just simply have write a program. We want to write a program that will allow for values to be entered. And at this point, we have a lot of values to be entered because we're really just moving along with integers at this point. Okay? Time will come where we will, play around with probably like a little more data, like text and stuff. Maybe in this class, maybe not if we have the time. But not this class today, but I mean like these sessions. But for now, a lot of what we're doing is just to set the groundwork and keep the just numbers, right? So we're doing stuff basic. So we want to write a program that allows for values to be entered, right? To be entered and accumulated. The program should state, or let me see, the program terminates accepting values when a value of less than 0 is entered. The program will then print a count of the number of values entered, the sum of the number of values entered, and a record of the highest and lowest values entered. Okay, so we have a couple things to keep track of. We have to know how much values were entered, valid values, valid numbers that were entered. We want to know a total of the values entered. So what does everything add up to? We want to know what the highest value entered was. We want to know what the lowest value entered was. Okay? So we have 4 things to output. And what we need to do is that we need to keep on asking, are we going to do this? We're going to do this this exercise using a while loop, and then we're going to use do this exercise using a do while loop. And we will see the difference. We will see the difference in doing these exercises. All right, folks? So let's try and think through what we would have needed in terms of variables. Let me ask for some assistance because I old and I really can't be hitting my head to think about all of these things. So Musa, are you there?
Yes, sir.
Right. I want some variables. You can give me some variable names. What variables have you identified so far?
Give me a second.
Mm-hmm.
See, why must I think and something?
All right. Well, I want to know where Musa go on.
Yes.
Yeah, I'm right here. I'm just reading over the question.
Okay. Well, we give him Musa 2 minutes. It's just all right. So Musa, we're dealing with integers. So we have to declare what?
Right. So we're gonna integers. You have to get
Right.
count. So put a count.
Account. Okay. What else? So we have the count of the numbers. Okay, we have N1 as the number that will be entered.
Mm-hmm.
What else do we do? What else we keep in this record of? Right? Okay, chime in. Assist him. Thanks, Musa, for the 2. What else do we need?
Oh, you have to get a minimum and a maximum.
Right, so we have min, we have max, and we have one more. I see it. Anybody could give me
And so, some.
some. Thank you. But we have to note some things about some variables. Thanks very much, Musa. Could anybody tell me a certain characteristic or property of some variables that we have here? They're going to have to be initialized in a special way. Anybody want to
Say you will have to say count is equal to 0.
Yes. And what else? Count is equal to 0 and what else? We have one more.
Also,
Data array.
No, we're not using arrays.
also your sum, sir.
Right, sum is equal to 0. So we have 2 variables inside here that are considered accumulators because the count keeps a count of number of values entered. That count could end at 0, it could end at 5,000, it could end at 500, it could end at 2, it could end at 2 million. All right? That count and the sum, they're accumulators. What that means is that they have to start at 0. Okay? They have to start at 0. And the reason that we're starting them at 0 is because if it is that I don't initialize them, what value is going to be in the variable when I do start to count? If I never initialized that variable, then how can I keep a count? Okay? So it's kind of like I'm saying, I'm thinking of a number. What is that number plus 1? Clement, answer me that question.
The number plus 1 will be 1, sir.
No, that's not the number I was thinking of. But good try. I wasn't thinking of 0.
You
Right?
sure, sir?
But I'm sure. Okay.
Alright,
So the number I was thinking of was 42. Right? But that's what you're basically doing if you don't for an accumulator variable. If you don't for an accumulator variable, set a value to it, an initial value to it. That's what you're doing. You're basically saying, okay, well, whatever variable the computer can assign to this number when it's created, just add 1 to it. And that's dangerous stuff. Because in this case, we want some accurate value. So this is why we have to start off count and sum at 0. All right. And it might seem like I'm talking about this a lot, but this is something that you just need to consider to put your mind in that space. Okay. All right. Next up we have, what do we want to do? We have to get the first value. So we have to say printf, please enter a number. And then we go scanf, and we go %b, sorry, no comma, ampersand n1. Because that's where we're storing this number. And what is our condition to start looping? Our condition to start looping, we say while what? While n1 is not in equal, is greater than or equal to 0. Because we say any number less than 0 will stop the looping. And look at this, the way that we structured this now. We have a prompt that says enter a number, and we taking in this number, and I need to put my get char here. All right, get char. Yes?
I think you had the pretty while loop. You have n1 is less than or equal to 0. Is that?
Oh, sorry, yes, sorry. Greater than or equal to 0. All right. Thank you for not leaving that as it was and then letting me feel spectacularly when we decided to run it. Okay. So while n1 is greater than or equal to 0, what do we want to do? We want to loop. So only when, right, only when n1 is bigger than 0 should we go into this loop. What do we want to do when we're inside of this loop?
Excuse me, sir. Quick question. What does the get char do, sir?
The get char cleans up input from the scanf. So sometimes when you press enter on your keyboard, right, you have the number, let's say for instance, you get a number and you enter 9, some invisible characters like \n \r goes in. Because this is an integer, the 9 is stored in the variable n1. That \n and \r gets kept in essentially what is the input buffer, right? And I've given you all a quick and dirty explanation here of the computer system. And what happens is if it is that I have more input in the future without those get chars to clean it up, these input buffer inputs could kind of stack up, right? So if it is that I do use a get char in the future to pause screen output, it'll actually just clear out one of these from the input buffer. So as long as I put get char after scanf, what happens is that when I do enter my value like 18 with the \n \r and 18 goes into the variable n1, the get char cleans this out one time. So the next set of input you put in is absolutely clean.
So it's just to
at the end of the day,
so it's just to keep the computer clean from
it avoids certain unwanted behaviors. It avoids certain unwanted behaviors that you might experience later on, right? So it's just one of those things that I've gotten in the habit of doing, especially with this. As I keep telling people, I can't remember having to do that in 2001, 2002 when I was learning C on a Turbo C compiler. But for some reason, CodeBlock's compiler and even DevC compiler requires it to be done in this day and age. I don't know if it's just time make me forget it. I don't even remember doing it when I first started teaching C to sixth formers. But I don't know, at some point the behavior started and putting get chars was the only way to solve it. And it was a fix, so it worked. I could live with it.
You're talking about how the compiler is corrupt sometimes? Okay.
Not necessarily corrupt per se. It works. It's just that you get extra input behavior so that when you try to do a screen pause, not using like a sleep function, but using a get char where you want a keystroke input, it does not allow for that keystroke input until you clear out.
Okay.
Right? So, but don't worry about it. To me, it's just one of those things. That's the behavior of the compiler. I just do it. Yeah, I just do it. Right? And it works, so it works. While n1 is greater than or equal to 0, so while n1 is a valid value, what do I want to do? I want to, first things first, carry my count up by 1. So count plus plus. Right? So I could say while n1 is valid, what do I want to do? Carry count up by 1. What else do I want to do? I want to add right? I want to add the value of this valid number, N1, to the total of sum, because I want to keep a sum of all the numbers that I have. Okay? So I can say,
So if you wanted to carry the count up by 2, what would you put?
I was now about to show you how to do that, but with sum.
Okay.
Yeah. Right? So it's not like count plus 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 or count plus 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 plus. It was like 9 or something. So no.
Can you just
Right?
put count bounded? Sorry.
Huh?
I was gonna say, can you put count is equal to count plus 2? Count plus 2.
Yes, you can do that. Right? You can put count is equal to count plus 2, or in like the case of sum, you can put sum is equal to sum plus N1. Or if you want to shorthand it, you can put sum plus equal N1. And this is the same as saying sum is equal to sum plus N1. So it's just shorthand. So if you wanted to carry count up by 2, right, you would have put count plus equal 2 to answer your question.
So
right? Would carry.
Could you put count plus equal 1? Like, or would that not work? Okay.
Yeah, count plus equal 1 would work. But then that's an extra keystroke over count plus plus. All right?
We're real easy.
Huh?
So I say we're real easy.
Well, yes, programmers are the laziest set of people out there. So, I mean, why type 3 keystrokes when 2 would work? Okay. So this is shorthand. We learning some shorthands here. Sum plus equal N1 is the same as, right? Sum is equal to sum plus N1, which adds the value of N1 to sum. Okay? So we're moving forward. Sum is equal to sum plus N1. Next thing we want to do, is this the first value? How are we going to record the highest and lowest value? Well, the people who with me in class know how we'll approach this. We know that the first value entered is automatically going to be the highest value and the lowest value. Agree?
Yes, sir.
Yes. So we could say that. We could say if what? If count is equal to 1. So if this is the first value entered, what does this mean? It means that, and watch another piece of laziness that you could do here. You could say min is equal to max is equal to N1, which will put the value of N1 into max, which will then put it into min. Okay? So the value, right, the first value entered is assigned to both max and min. And if it is not the first value entered, then we have to do some checks, right? If it is not the first value entered, then what do we have to do? We have to do some checks. We have to check to see if the current value is bigger than the minimum value, is bigger than the maximum value, and we have to check to see if the current value is smaller than the known minimum value. Because only on the first value are you sure that this value is the biggest value and the smallest value. You all follow me?
Yes, sir.
Right? Simple case in point. I'm checking to see I have numbers. I want a volunteer. Let me see. From my volunteer, my list is going to be Elon. Elon? Is Elon there? No? All right. Kyra. Kyra, you there?
Yeah.
All right. So Kyra, out of the list of numbers on the screen that I am going to put, I'm going to ask you to enter some values, okay? So to tell me which is the biggest, which is the smallest. So if it is at this point, my nums, right, my value of n1, and then I have min and I have max. And I say, okay, this is right now 9. What's the minimum value?
9.
Right, what's the maximum value?
9 again.
Right, so my next number is 3. What's my minimum value?
3.
Yeah, because it's smaller than the known minimum. What's my maximum value?
9.
Right, so it stays the same. 2, what's my minimum value?
2.
Right, what's my maximum value?
9.
Right, and then we have 15. What's my minimum value?
2.
Right, and my maximum is?
15.
Right, and then I enter -1. What's my minimum value?
Well, they had to stop because it's a
Exactly. Thank you very much, Carol. So we stop there. That's what we're trying to get out of this. So what we know is that for the first one, the first value is always going to be the minimum and the maximum. For the second one, we now have to check and see if that value is smaller than the minimum, and if that value is or if that value is bigger than the maximum. And that's what we want to do inside here now. Okay? So I realize I don't have no notes for this week because I'm not writing anything down, but we have the programs and I'll send the programs to you guys. Okay? As long as I could find where I'm storing them on my computer. Okay? So the first thing that we'll have to do is we want to say if, right? If what? If n1 is smaller than min. If n1 is smaller than min, what do we want to do? We want to say that min is now n1. And then we want to do the same if n1 is larger than max, then we say max is equal to n1. So what am I asking here? I'm saying if this current number is smaller than the known smallest, make it the known smallest. Likewise, all right, and again, laziness killing me here. I'm going to copy and paste and just change the word from smaller to bigger and smallest to biggest. Make it the known biggest. Okay, so make it the known biggest. And you'll notice that for some of these lines, I don't have curly brackets. There's a rule in C programming that says if it is that you only have one statement following an if statement, you don't need to put the curly bracket. Okay? So, it'll work without that. But if it is that you have to have more than one statement, then you need to put the curly brackets to indicate what who is under the control of this if statement. Again, another little easy thing that programmers do. Okay? If it is that you can't remember that rule, always put your curly brackets. You all could agree on that? Or if you just prefer how it looks, right? Some people just prefer to see the curly brackets. there is no crime in putting them curly brackets there. Okay? I think I thrown off a curly bracket somewhere. Right? Oh, I'll put it backwards. Right. So you can put your curly brackets in. However you like it. But as long as you follow the rules. Okay? Okay, folks? Oops. Yeah?
Yes, sir.
Everybody sitting here.
Yes, sir.
Oh, okay. Right. So now that we have this inside of here, and you notice that we have some curly brackets that now kind of all over the place. Sometimes when I have this kind of structure, just to not confuse anything, I go end if, and while. So I know where my curly brackets, who my curly bracket belongs to. Okay? And now I want to, now that I've put the logic inside of here, I want to be able to, print out my values. What am I printing out? I want to print out the values associated with count, sum, min, and max. So I go printf, and I'll say count, right, or number of values entered is $d, and I'll put count here. I say printf right. I say sum of values entered is $d, and this is sum, and I say max value entered is $d, and I say max, and I say min value entered is $d, and I say min. And anybody see a problem with what is going to happen to my output? Anybody see a problem with my output?
All of it will be on the same line, I think.
All of it is going to be on the same line because I have nothing stating to put each one of them on their own line. So for me to be able to do this, and let me just do it as an example without putting it, separating the line so that people would see. If I enter 3, I didn't put the ampersand. Please enter number percent. Yes, I did. All right, sorry. 3. My program is hanging. All right, what is going on with my program? I also have another problem here. Does anybody knows what is wrong with my program?
So you didn't put the other, please enter number.
Yes. So my program is looping infinitely. Because what happened is that my program has taken the value of 3 inside of N1. This here is always going to return the true at this point. It's going to do this, reach the end while, come back up here. And what is the value of N1 at this point? It is
3.
3, which is true. So it's going to go on, do this, come back up here, and it's still true. It's going to come down, do this, go back up here. It's still true. I've gotten into an infinite loop. So this loop is going to keep going and going and going because I've never changed the value that is going to be responsible for stopping the loop. Right? And that's my own fault. So right before the end while, I have to ask for a new number. I have to ask for a new number. So please enter a number. If I enter 3, now I hit this, which will eventually allow me to enter a number that will allow me to come out of the loop. Right? 3, 4, 5, 6, 7, 8, 9, minus 1. Number of values entered. I've entered 7 values. These numbers, 3, 4, 5, 6, 7, 8, 9, add up to 42. The max value entered is 9, and the min value entered is 3. Okay? Let's put them in a less of an order so we can make sure that, we have 3, 2, 6, 1, 7, 9, 3, 8, 19, minus 1. So we see that the max value entered is 19 and the minimum value entered is 9. But that's a kind of eyesore to read. So let's put them on each on their own line. To do that, we have to use \n. This here is a single character. It's a single character called a new line character, which allows me to go to the next line on my output console. So this \n is an invisible character when printed out. This \n is an invisible character when printed out. Everybody with me here?
Yes, sir.
Yes, sir.
Mm-hmm. So when I run it, and I run my program, 5, 7, 6, 3, 8, 9, 2, 1, 0 is a valid character, 3, or a valid entry, minus 1. I entered 11 numbers. They were 52. Max value is 9, min value is 0. And they're all on separate lines. So notice that, that this \n here,
So can't you put a /n like before the sentence, like after the quotes and before the notes, so you can separate from this output?
Printf. So you don't like how close it is?
Yeah, I mean just one before the note would be fine.
Okay, I'll put 3
instead of having
so that we could. So it come out with a little space. Okay, so it's 3 lines, 3 lines space. That's much better. Yeah?
Yeah, look nicer.
All right, or even you could put \n and a couple dashes and another \n. So that at least, it'll look a little classy. Yeah? So we now have this here. Yeah. We have this here, and it's, it just gives us a little spacing. It's good for input output. So I'm glad that you guys are seeing that. And you all could start to appreciate, formatting and stuff like that. We want to do the same exercise. As using a do-while loop. Okay? We don't have much time again, but I do want for us to go through the do-while loop. It's not going to take as long as the while loop. And then I want to give us 1 or 2 little exercises, quick programs to write. So we might be finishing closer to 6:30 tonight. That's fine?
Yes, sir.
Yes, sir.
All right, good. So we want to start up a new one of these. All right, empty file, C files. Let me just see my path here. Supplementary. Oh, okay, it's in my OneDrive. right? So I'm going to name this do underscore while dot c. And do not put, just, if you notice, I always put like a underscore instead of a space. Don't put spaces in your file names, okay? If you do, Computer Mafia will find you, all right? They'll rough you up. It's not going to be nice. So we want to use a do while loop here. And the only difference that we have, actually I could copy over the whole program using a do while loop. But let me at least copy over up to here. And I'll pull parts from the next program as necessary. All right. So I'll pull parts from the program as necessary. So we have this year, we have our same count N1 min max sum. But we want to implement this using a do while loop. And the difference with a do while loop is that we are going to have to do the instructions at least once or more times, right? So we have execute instructions one or more times. So what I have here is I'll have the word do. I'll have the word do. And I want to do something while N1 is greater than or equal to 0. And you notice for do while loop, you have to put a semicolon at the end of the control statement. This is the only time that you really kind of do this, right? You don't do it for the for, you don't do it for the while, you don't do it for the if, all right? But you have to do it for the while loop, the do while loop, sorry. What do we want to do? Well, the first thing that we want to do is we want to ask the user to enter a number. Okay, we want to ask the user to enter a number. So we put in this inside of here. Please enter a number. And we're doing this as long as the number is bigger than 0. Because this is what we want to really and truly capture to do one or more times. But what we don't want to do, if this number that was entered is less than 0, is the rest of the stuff inside of here. So we don't want to do this stuff unless the number is larger than 0. So we could just fix that by saying if N1 is greater than or equal to 0, and paste this information inside of here. Okay, so if N1 is greater than or equal to 0, then you could carry the count up by 1, because now it's a valid number. And you could start calculating the sum and checking to see where's min and max and all of that. Okay? Everybody understand what we do here? This is almost identical to this there, except that we also don't have to put another request for a number down here, right? Because we have the number inside of the loop. So if it is that we get this number, whether or not we do this, we then check to see whether we should continue or not. If we should continue, we will get another number. If we don't continue, then we will exit the program. Okay? And of course, the same thing for down to the bottom here. Really and truly, it's about the same. All right? You just want to print your output. So these two programs are identical. You see how quick, how close the while and the do while is, even though there's a shift in logic. Because you want to do this, you want to get a number, right? But you only do these operations if the number is valid. Are you with me?
Yes, sir.
So for example, if you use -9, then you wouldn't use that.
If I use what? If the
-9.
first number entered is -9, the program is going to just stop. Right? You notice that min value entered is 16, right? Max value entered is 0. These values were never initialized. So these values are just going to have garbage inside of them. So really and truly, and that's something that's notable. Let me see what happens if I just enter -8. Okay, it's still same garbage coming up, right? But what maybe that should indicate to us here is that maybe we should only print these out if count is greater than 0, then we should print these values out. And let's do the same thing in the do while loop, right? So let's just run it to see how it'll work. -9. So we don't have a min value or a max value to enter, so don't display that. The same thing for down here. All right, so you see how a little bit of testing can help us improve our program as we go along. And it just takes one little line inside here to just improve it in terms of making sure that garbage values don't come out when unnecessary. These concepts will take you into every aspect of programming, whether you choose to do database programming, whether you choose to do web programming, whether you choose to do app development, whether you choose to do some kind of system programming or computer applications. But these are the things that we could look for, because you don't want to display information to users that's not accurate. We never set a value for min and max, so why should min and max be printed? Okay? We know for a fact that count and sum are 0 because we've set 0, and that's what they are, because a valid value was never entered. Are you with me, students?
Yes, sir.
All right, so we've come up with some code for loops, while loops, and do while loops, right? We actually dealt with the do while much faster than actually I had not thought that we would have dealt with it. Excuse us. Yeah. All right, so I'm going to share my screen and put up an exercise on the screen. So give me a second to put the exercise on the screen. And I'm going to give you guys some time to do the exercise. Okay? So the exercise, I'm going to put it on the screen right now. Hold on. Right. Right. So we want to write a C program that allows a user to enter 2 numbers, and the program will print all common factors of the 2 numbers entered. Okay, so this is the first one, and I'm going to add another one there. All right. Anybody feel like they don't know how to approach this question at all? or you can't remember maths and you can't remember what the factors are or anything like that. So if I enter the number, if I enter the number 12 and the number 8, right, my output here, okay, should be 2 and 4. That's what I'm looking for as an answer from this program. Everybody understand what I'm asking for in the program?
Yes, sir.
Yes, sir.
Right. You feel like you could handle it? You could write a piece of code to do this?
Yes, sir.
Okay. All right. And the second question, 2 very short programs. They shouldn't be too long. Right. And numbers. And all right, so the second one is to write a C program that allows a user to enter numbers into it and only stops when the sum of all numbers entered is divisible by 7. Okay? So if it is that I enter values into my program, I'll have to enter, so for example, 3, right? It'll ask me to enter another number, right? 5, it'll ask me to enter another number. 8, 6, it'll stop there, right? Because I believe 3 and 5 and 6 is 14, not so? Yes? So it'll stop there because the sum of all these numbers is divisible by 7. All right, so I'm going to stop the recording at this point. I'm going to give you 20 minutes to do these 2 exercises. And then after we will come back and work on the solution. Okay?
Yes, sir.
Okay. Recording, and I'm sharing my screen. Everybody seeing my screen, right?
Yes.
So we're tackling the first question, which is asking a user to enter 2 numbers, and the program will print all common factors of the 2 numbers entered. Okay? So we can have include stdio.h, include s int mean. All right. All right. So we want to start off, and I'm gonna use something pretty similar to what I did earlier on. Just give me a second here, and let me open. Right. So I'm going to borrow some code from here. Pretty much this code. That will always allow me to have the larger number in N2. Okay? So the larger number will always be in N2. And what I want, what I basically want to do is if I have two numbers, if I have, let's say, for instance, 6 and 8, I will run a for loop up to essentially the smaller number. Okay? And what that will allow me to do is, okay, I check number 1, yes, that's for 6 and 8. Number 2, yes, that's for 6 and 8. Number 3, yes for 6, no for 8. So we don't output it. Number 4, right? No for 6, yes for 8. Number 5, no for 6, no for 8. Number 6, yes for 6, no for 8. So at the end of the day, only where the two values are checked off do I print that number to the screen. Do you all understand the logic behind what I'm doing? I'm about to do?
Yes, sir.
Right? Good.
Yes, sir.
So I would say, right. So I would say for I is equal to 1, semicolon. So I'm starting at 1. I'm going until I'm at the smaller number, which is going to be N1. Okay, so the smaller value will always be in N1. And I will go N1 plus plus. What am I going to do? I am going to
Excuse me, sir.
Mm-hmm.
Can't you have a little bit of code to find the small number and then put it as N1?
This is the code that will do that.
Oh,
This
okay.
piece of code here, right? Well, if N1 is bigger than N2, it will swap N1 and N2.
Right.
Right? So go from 1 to the smaller number. And what do we want to do from 1 to the smaller number? We want to check and make sure that whatever I is a common factor. So I'm going to say if what? If, sorry, not quotes, if N1 mod I is equal to 0. Sorry?
For the for loop, why would it be N plus 1?
Oh, no, sorry, that's I plus plus, not N1 plus plus.
Yeah.
Apologies. If N1 mod 1 is equal to 0 and N2, not mod 1, mod I is equal to 0 and N2 mod I is equal to 0, what do you want to do? You want to print out the value of I. So %d \n, and you'll print out the value of I. So if the value of I divides both N1 and N2 without remainder, print that value. Okay? So this should be it, more or less. Let's check and see. So two integers separated by a comma. If we have 16 and we have 7, the only value common to both of them is 1. Okay? If we have two integers, let's check 64 and 16. Right? Both these values have common factors of 1, 2, 4, 8, and 16. This seems correct enough?
Yes, sir.
Everybody understand how I got to my solution?
Yes, sir.
Okay? We use this process that's on the side here only when we are at a particular number. So what is represented on the side here, these values here, is the variable I. This is N1 and this is N2. Okay? And once they're checked off, then we would have seen those values printed out. Clear screen. All right. So the next one is going to be the next question. Sorry, is that we have a C program that allows a user to enter numbers into it, and only stops when the sum of all numbers entered is divisible by 7. So this is the last thing that we're going to work on today. I'm going to zoom in a little bit to make this a little more readable. All right, I'm going to name this div7.c. So again, we're going to include stdlib.h, include stdio.h, int main. And what are we looking to do here? We are looking to make sure that only values that are divisible by 7 stop the looping. Okay, so we have int num comma sum is equal to 0. So again, there's an accumulation here. And we can say do what? Do what do we want to do? We want to print out, printf, please enter a number. Okay, we have no restriction on whether this number is positive, negative, 0, whatever. So we can scanf this number into %d and %num. So we store the number, and then what do? We will add this number to sum. So we say sum, right, plus equal to num. And of course, this plus equal works for negative. It could have negative equal, would be sum is equal to sum minus num. It could have multiply equal, which would be sum asterisk equal num, if it is that you had to multiply, right? So we add the number to sum, and then we say we want to do this while what? While sum modus 7 is unequal to 0. So what am I saying here? Do this until sum is divisible by 7. Okay? And once sum becomes divisible by 7, that's where we stop. Okay? We didn't even ask to enter, to print out sum or anything like that. So if we run it, I enter 7 as my first value, I stopped because 7 is divisible by 7. If I enter 8, 4, 67, 2, 89, 9, 2, 2, 3, 1, 1, 1. Now we eventually hit a number that's divisible by 7. Okay? Everybody's fine with this?
It's see, wait, when you can pull up the output screen again, sir?
Oh, I already closed it off.
Oh.
You want me to do it again?
Entering the program stuff when you enter 1?
No, I entered 1 until it reached a value that was divisible by 7. So I could print out, right? Hold on. Sum is %d. So let's see. 8, sum is 8. Ooh, did I put a backslash n? Oh, no. It would tell me that because the scanf has that backslash n innate to it. So, okay. session. Right. So 8, 56, 37, 91, 1, 1, 1, 1, 1, 1. So 238 is apparently divisible by 7. We could check and see. Right? So 238 divided by 7 is equal to 34 exact. No remainder. Are we good there?
Yes, sir.
Yes, sir.
Understand.
Yes, sir.
Okay. All right. So what did we do today? It seemed like we do a whole lot. I know I can understand if at this point your brain feel a bit like it's on fire or something. So, right? Because we ended up getting through quite a bit today with regards to the amount of stuff we did, especially with looping. We went through the 3 major structures for looping. We went through the for loop, we went through the while loop, and we went through the do while loop. Okay, we also took a look at some concepts like accumulation, right? We looked at the count, we looked at the shorthand for certain things. So there is a little bit to remember inside of there, okay? But trust me, you guys are doing well. From what I'm seeing, just keep on at it. It's about keeping practicing. You're going to get it. As I said, a good thing to do, right? I'm going to put up these programs up online. But what you could do is, remember, I have at the beginning of every program what the intent of that program is. Copy that out, and you try as a question, knowing that the answer is there, to reproduce that. So that, even if it is that you don't get to reproduce it, you could take a look at what I have as opposed to what answers are there and see where you fall short and what you need to do to get to programming well. Okay? Before I leave, any questions? We were kind of in it for the long haul tonight. Any questions? No questions. All right. So I will try and have this stuff up by tomorrow evening up on the Google Classroom. I'm going to stop recording now. And